Hi everyone, what's up? In this video, I'm going to explain some of the RDD operations which are very common in Spark interviews. These are map, flatMap, reduceByKey, sortBykey and groupByKey. These functions are mostly used in RDD transformations and actions. You might be either given a coding question to solve, or you might be asked to explain the function with an example. Other than this, lot of time interviewers try to test your knowledge by asking the difference between few of these functions. But don't worry, as we will not only understand each of these functions, but we will also write some code using sample data to make things more clear. If you are preparing for data engineer jobs, then do check out my videos on data engineer interview experiences. The link is in the description as well as in the I button. In those videos, I've covered all the important questions from SQL to Spark from each of the interviews that I had attended in the past 1 year. Try to watch all of them because it will be very beneficial for you, but do that after you have seen this video. Also, if you're interested to know how I got shortlisted in all those interviews, then do check out my video on how to get shortlisted as a data engineer, both junior and senior role. In that, I've covered many tricks and techniques from resume creation to how to apply for the jobs and how to get shortlisted at the end. So feel free to check that out as well. Finally, let's start with today's topic. So here we are on the Databricks notebook. So as you can see, I've listed down the topics for today, which is map, flatMap, reduceByKey, sortBykey and groupByKey. So below is the source dataset, which I'm going to use with couple of these functions, and for the others there might be some other dataset. And not only are we going to understand what each of these functions do and how to apply them, we're also going to take some common interview questions like difference between reduceBy and reduceByKey and various other such questions. So let's not waste much more time. Let's move on to the map function. So what is map function? Map in Pyspark is a transformation function that is used to apply a function or lambda to each element of an RDD. You can use this for simple to complex operation like deriving a new element from existing data or transforming that data. So data frame doesn't have map transformation to use, hence you need to convert data frame to RDD first. So first let's take a look how you can apply map to an RDD. So I am using the above RDD and you can see this is the data. I've printed it out. So in this particular RDD, what I'm going to do, I'm going to apply map, and to each of the element I'm just going to adjoin a 1. So as you can see, I've done lambda x and x comma 1. Here x represents each element of an RDD, and rather than doing x comma 1, you can also do x plus 1. So it will just concat 1 to this particular element. So this is how you can transform each of the element in an RDD. So I hope this thing is clear. You can even try it out. The notebook link is in the description. Now let's see how you can apply map on a data frame. So I'm using this sample data frame. The data is printed out here. So we have first name, last name, gender and salary. So what we are going to do is we are going to apply some transformation to the columns of this data frame. What I'm going to do is I'm going to convert the df to RDD first, because map function can only be applied to RDD. It cannot be directly applied to a data frame. So once I've converted it to RDD, this is the syntax. Then I'm going to apply map, and I'm going to use a similar kind of syntax. I'm doing lambda x, and here also x represents the entire data frame. And if I want to grab each column, then I have to use something like this. So x0 represents the first column, x1 represents the second, and so on. So what I'm doing here is I'm applying transformations to the columns. So the first thing is I'm doing first name comma last name. This will return me something like this. The second column I'm doing nothing. I'm just passing it on. And the for the third column, I'm increasing the salary by 2. So I'm multiplying 2 to this particular column, which returns me this value. So you can see we had 3000. I'm multiplying 2 to 3000, which gives me 6000, and the other values as well. So 2500 into 2 gives 5000, and 1800 into 2 gives 36,000. Now once you have the result stored in an RDD, because map also returns an RDD as it is a transformation, so what we have to do is we have to convert this RDD back to a data frame. So here is the syntax for that, RDD map.toDF, and inside it you can give your schema. Now if you take a notice, the initial source data frame had 4 columns, but what we did in the transformation, we created only 3 columns. So this one is the first column, then we have a comma, then this is the second column, and then this is the third column. So similarly, you can even increase the column. You can do something like James plus Smith in a fourth column or in a third column, and no need to add the comma, just add a space. Or you can again increase the salary by 3 times in a separate column. So you can keep on increasing the columns in an RDD, and once you are satisfied with your result, then you can convert the RDD to a data frame this way. Just remember, if your data frame has 3 columns, then your schema should also have 3 columns. Finally, I'm displaying the result here. So this particular result looks like this. Now, once we have gone through how to apply map on an RDD and how to apply map on a data frame, let's take a look how to create a custom map function. So here we are. So I've written a normal Python function that is called map_func. What I'm doing here is I've created a variable called first name. So the first name grabs the value from X. So X here represents a data frame. We are going to see later how does it matter. So X.firstName, basically the data frame's first name value comes to this variable. Similarly, X.lastName. So the data frames, this data frame's last name value comes to this element. Now what I'm doing is I'm applying a transformation here. So name equal to first name plus last name. But this is not a data frame transformation, right? Because there is a Python function. You're just normally concatenating 2 strings or 2 set of columns here. So at the end, I'm returning the name, gender, salary, whatever I've incurred in whatever I've calculated in this function. And once I send it back here in this particular line where I've done df.rdd.map and lambda x equal to map function x. So this again returns me an RDD element. So this RDD result is nothing but a new RDD created out of the transformation that has been included in the map func. I hope I'm not confusing here too much. What you can do is you can just copy this code from the notebook and try to change the transformation into something else. Maybe add a comma here, or maybe convert the gender to uppercase, or add a new element or a new column entirely below this. So once you are satisfied with the result, again you can print it out. So what I've done here is first I've printed out the RDD result. As you can see, this is our RDD result. And post that, I have converted this RDD result to a data frame. Similar to the previous example, I have included a schema where the first is name, gender and salary hike. And once I have converted the RDD to a data frame, here is the final result. So this is all we have in map. If you know this much, and conceptually if you know what map does, then that is enough for the interviews. But what I will suggest is, from this notebook, just try to change the examples a bit into something else, like try to add a new column here and there. Try to play around with the transformation. That will only make you understand map much better. So now let's move on to flatMap. Sorry for interrupting, but before we move on to the next part, I have a small request from the community. I can only see 13% of people are subscribing to my channel. So if you have learned something useful today, then please push the like and subscribe button. For you it's free, for me it's a source of motivation to keep making more such videos and assist you in your learning journey. So the next element is flatMap. Now what is flatMap? Pyspark flatMap is a transformation operation that flattens the RDD after applying the function on every element and returns a new RDD. It's particularly useful when you want to flatten the output into a single list of elements. Another common usage when dealing with text data, where you want to split the lines into words. Unfortunately, Pyspark DataFrame does not have flatMap transformations. However, DataFrame has explode SQL function that is used to flatten the columns. So I'm not going to discuss the explode function here in this video. In some other video with using some example, I'm going to explain you. But let's take a look at both the examples. So the first one is used to create different cardinalities. Now what is cardinalities? Basically, let's say you have a set of 4 elements. Now after you apply flatMap to it, it might be increased to 13 or some elements. That depends. So cardinality means the amount of elements in a set. Now what I'm doing is first I'm creating a ranged RDD. So the ranged RDD's first parameter is 5. Basically it will start from 5 and end at 10, but it will not include 10. Now I've given an offset of 1, so it knows that first element will be 5 then will be 6, then will be 7. So that's how it has generated 5, 6, 7, 8, 9. So this is our input. Now I'm going to apply flatMap on this particular RDD. Now the syntax is similar to how it was in map. You can see lambda x, and this x represent every element in this RDD. Now what I'm doing is I'm telling the flatMap that for every element you generate 3 more elements. Out of those 3, the first one will be as it is. Second one multiply 2 to it. Then the third one multiply 4 to it. Now let's take an example here. The first element was 5. Let's take this. So I'm telling the flatMap function what to do. I'm telling it first keep 5 as it is in the result. Then you multiply 2 to 5. That gives me 10. And finally you multiply 4 to 5. That gives me 20. Let's take another number. Let's take this 6. So I'm saying it first you keep as it is. Then you multiply 2 to 6. That gives me 12. Then you multiply 4 to 6. That gives me 24. And so on. You can recheck all these numbers. So I hope the working of the RDD, working of the flatMap is clear and what it tries to do. And one thing to note here, as I was saying, it increases the number of elements in the result. The input set had 5 elements. The final set has way more than 5 elements. So now let's take a look at the next example. So the next example or the next use case is if you want to split a text file. Here I'm not using a text file, I'm using a sentence only. So you can see I've created an RDD which consists of a single element, and that element is if we want to split a text file. So this is a string element. Okay. Now what I want to do is I want to separate out each of the words from this sentence. So if should be a different element, you should be different, want should be different, and so on. So how to do this? We have to use flatMap. So you can see I've applied flatMap on RDD text, and the syntax is lambda x colon x dot split, and this thing is called a separator. So split is similar to what we have in Python, and the separator is a way of telling flatMap that you want to separate out each of the element based on space. Basically all the elements are divided by spaces. So this is one space, so another space is this. So all the elements between these spaces should be grabbed and made it into a new element. Now once we have executed this, you can see my resultant list or resultant RDD has if as a new element, you as a new element, want as a new, and so on. So I hope this flatMap example is clear. So what you can do, just like the previous example, you can take this notebook, try to run it, and I would leave something to you. That is, rather than using a text file, rather than using a sentence, try to read it from a text file and apply the same syntax and see what happens. So I hope this is clear, and let's move on to the next question. So moving on to the next question, what is the difference between map and flatMap? So this is a very common interview question. Let's take a look. Map is used when you want to do a one-to-one transformation where each input element corresponds to exactly one output element. So if you have 5 input elements, map will generate 5 output elements only. Now what flatMap does? flatMap is used when you want to perform a transformation that can generate 0 or more output elements for each input element, and you want to flatten the results into a single RDD. So we have seen in the previous example, let's say you have an RDD which has a single element. Now flatMap, after applying flatMap to the particular RDD, the output can have 0 or more elements. So now let's try to understand this using some examples. So in this example, I'm using ranged RDD, which I showed you earlier. The input has 5, 6, 7, 8 and 9, and basically it has 5 elements. So first let's apply flatMap to it. This is the same thing that I showed you in the previous examples. So what I'm telling flatMap is, keep the first element as it is, multiply 2 to the first element, and then multiply 4 to the first element. But all these 3 elements will be added to the new RDD as new elements. So you can see 5 is a separate element, 10 is separate, 20 is separate, and so on. Now let's apply map to this particular RDD. So as you can see, I've kept everything as it is. Only difference is here I'm using map. What it does is it transforms the first element into this, transform the second into this. But if we count the total number of elements inside this result, it is same. So we have 5 elements here. Here also we have 5 elements. The only difference is this particular element itself is an RDD, which consists of three more elements. But in totality, if I find the length of this RDD, it will give me still 5. So this is the main difference between map and flatMap. I hope this is clear, and let's move on to the next function. The next function is called reduce. Reduce is an aggregate function which is used to reduce a dataset to a single value. The reduce function requires 2 arguments. First argument is the function we want to repeat. Second one is an iterable that we want to repeat over. It is commonly used to calculate aggregate values like min, max, sum, etc. So first, let's take a look at the syntax. So I've created an RDD here. You can see I've used 1, 2, 3, 4, 5. And using this, I'm applying reduce on top of it. And it is similar to what we do in map or flatMap. So we have to use the lambda. And as I said before, it takes 2 arguments. So I've given here x and y. Now what I'm trying to do here is I want to add all these elements. So that's why I've done x plus y. Now how does this addition takes place? Let's take a look at this line. So you can see reduce will work something like this. The first element, that is 1, is firstly considered as x. Then I'm telling reduce that this element, that is y, that is 2, should be added to x first. Now the first bracket, that is 1 plus 2, will return me 3. Now the result of this bracket is the new x, and this particular element is y. So 3 here will be added to 3 again and will give me result that will be the result of this particular bracket. Now again, this bracket's result is the new x and 4 is the new y, and I'm telling reduce to add these 2. Similarly, this bracket's result will become the new x and 5 will be the new y, and it will be added, and that will give me the final output. I hope this syntax and as well as the working of reduce is clear. Now let's take a look at some examples. So in the first example, I'm going to show you some aggregate functions using reduce. You can see I've created an RDD here using these set of elements, and I'm going to apply these aggregates to the RDD. So let's take up the first example in which I'm calculating the minimum value among these elements. So you can see the syntax here, list RDD.reduce lambda x, y, and I'm just applying min on x, y. So what it will do is, in the first case, x, y will be 1, 2. So 1, 2's minimum is 1, then 1 will be checked with 3, again the minimum is 1, then 1 will be checked with 4, and so on. And similarly, all the other aggregate function will work. I've included multiply just to give you an idea that not just sum, but you can do minus, multiplication, divide, anything to a particular RDD. Let's move on to the next example now. So the next example is how to apply reduce on data frame. We know that reduce is an RDD action, but there is a way you can apply reduce on a data frame. So I've created a sample data frame here. You can see it consists of all these records, and the first column is number and the second column is values, which is of array type, and you can see the data here. So the first record is 1 for number, and for value we have an array of certain elements. Now what I want to do is I want to do a sum on this values column, and I want to get the sum of all the elements inside the array in each row. Okay, so how to do that? We're going to apply reduce for this. Let's see. So you can see here df.select. So I've just selected number, then I'm applying reduce here, and in this syntax I've given the column name first, then this is the starting value, then this is my function definition. So here lambda x, y, because reduce takes 2 arguments, and I'm just doing x plus y, just how I did in the above examples. Moving on, I'm giving it a name of sum. Now what it does is, in the values column, it will iterate through each and every element inside the array of each row, and then return you a sum. Basically reduce this entire array to a sum of its element. So you can see for the first record, for number 1, the sum is 205. 205 is nothing but addition of all these elements. I hope this is clear, and I just want to tell you that this functionality is new in Spark 3.5, and if I show you, so this is the official documentation, and I got the example from this, so you can check this out to get some more idea. Now let's check out the next function. So coming to the next function, which is reduceByKey. reduceByKey is a transformation which is used to merge the values of each key using an associative reduce function. It is a wide transformation as it shuffles data across multiple partitions and it operates on a pair RDD, which has key value pair. So basically, if we want to reduce a certain set of values based on their keys, then we use reduceByKey. Let me give you an example. So in this example, we are going to find out how many times each word occurs in below RDD. Let's take a look. So in this RDD, if I take a project, so you can see project occurs 3 times. And if I take up Gutenberg's, so it also I think occurs 3 times. So basically I want to know how many times each word occurs. Now before applying reduceByKey, what I'm doing here, I'll attach a counter value in front of each of these words. So I'm using map to do that, and I explained this in above example when I was explaining you map. So if I apply map and I do lambda x and x, 1, it will return me this value. So you can see each word has 1 in front of it. Now finally I will apply reduceByKey to get my actual result. reduceByKey reduces each of the words by applying some function to the value based on its key. So if I have a key value pair that is Gutenberg's and Wang, so reduceByKey will look for this key, which is Gutenberg's, in my entire RDD, and then it will add up all the values in front of this key. So you can see the final result looks something like this. So Gutenberg's was 3 times, and so reduceByKey went into this RDD and looked for this key element. Then whatever value there was in front of it, it just kept adding it. And it's not just like we can only apply sum here, we can also do a minus. So it is irrelevant on the question, but I just wanted to show you that other than sum, you can apply other accumulators here. So you can see when I apply minus, so it minus all the counters in front of the particular keys. So this is all I have in reduceByKey. I hope this is clear, and let's move on to the next function now. The next function is sortBykey. SortBykey is a RDD transformation function which is used to sort the values of the key by ascending or descending order. It receives key value pair as an input and then sorts it in a specified order. So let's take a look at an example. I've created an RDD here, RDD list, and you can see it consists of these set of elements. So there is C, 10, this is 1, then this next one is H, 4, and so on. Now if I want to sort this particular RDD, the syntax is pretty straightforward. So you can see you just apply RDD list dot sortBykey and once I do a collect, you can see it has sorted the list in this ascending order. Now by default, sortBykey sorts the particular RDD in ascending order, but if you want to do it in descending order, you just have to give false inside the sortBykey. As you can see, as L was the highest among all the keys, so it came first. So that's it. In sortBykey, it's pretty straightforward. Let's take a look at the next function now. So the next function is groupByKey. groupByKey receives key value pairs as an input, groups the values based on key, and generates a dataset of key and iterable pairs. It is a wide transformation that performs shuffling of data. It is suitable when you need to group all the values associated with each key. It can be memory intensive since all values for each key are collected and stored in memory. So in this example, I have created an RDD list out of these set of elements, and this is the result. So as you can see, the key C has multiple values. So here it is 10, here it has 12, then here it has 13, and all the keys have multiple values. Now I want to group all the values based on their keys. So how to do that? Here you can see I've applied groupByKey on the RDD list. The syntax is fairly simple, and the result here returns me a new RDD. The first value of each row in an RDD is the key. The second value is the iterable. Now this particular iterable consists of all the values in front of the key. In this case, because it is H, so it will have 4, then again 4 and 4. So how to grab this iterable, how to get the value out of this iterable? Let's take a look into that. How to get the iterable value and their keys after grouping. So as you can see, this is the result of RDD group key, which I showed you in the previous command. The first one here is the key and second one is the iterable. Now in order to get the values out of this iterable, you have to apply map. So you can see the syntax here, lambda x colon x0. So x0 is nothing but the key element and x1 is the iterable, and in order to get the values out of these iterable, you have to convert it into a list. So I'm doing a collect here and you can see the final result here. So H had 4, 4, 4, C had 10, 12, 13 and so on. Let's just compare it with the previous data. So you can see C has 10 and C has 12 and 13. Similarly, H had 4, again 4 and at the last again 4. So we got the correct values. Now you can also sort this particular RDD using sortBykey, in which the key is H, and because by default it sorts in ascending, so A comes first. I hope groupByKey is clear now. Let's move on to the some common interview questions. Based on the RDD operations that we just discussed, there are some common interview questions which are frequently asked. So the first one is difference between reduce and reduceByKey. Reduce is an aggregate function that reduces the data into a single value, while reduceByKey accepts key value pair and it reduces the value based on the key. And reduce is an action while reduceByKey is a transformation. So you can always refer to the example that I showed earlier for both reduce and reduceByKey. For reduceByKey, you can give this particular example where you first apply map and then you apply the reduceByKey and explain clearly what happens. While for reduce, you can just create a sample RDD and you can just perform an addition to this sample RDD to reflect what reduce means. I hope this is clear. Let's check out the next question now. The next question is difference between groupByKey and reduceByKey. So reduceByKey and groupByKey are transformation operations on key value RDDs, but they differ in how they combine the values corresponding to each key. So let's try to understand this using an example. First, I've created an RDD called RDD list using these set of elements and I've displayed them here. Now what I'm going to do is I'm going to apply first groupByKey and then reduceByKey to this particular RDD and display the result and explain you what happens. So first I've applied here groupByKey, which groups the data based on a key while keeping the values as iterable object. So this is the syntax, and I've also used the map function here to get the values out of the iterables, which we saw in the previous groupByKey example. So as you can see, the final result is something like this. We have the key and all the values that was associated with this key. Now if I apply reduceByKey here, so it reduces or adds if add operation is used, and the values on the values based on their keys. So this particular key, I apply add operation to all its value. What it gives me? It gives me 12. Basically 4 plus 4 plus 4. Similarly, if I add all the values of C, so it gives me 35. And this is happening because I have applied reduceByKey here. So I hope you understand the difference between groupByKey and reduceByKey. Now let's check out the next question. Coming to the last question of this video, what is the difference between sortBy and sortBykey? So both sortBy and sortBykey sorts the data in ascending or descending order, and the only difference between these two are their syntax. So let's try to understand this using an example. As you can see, I have a data set here, and using this I have created an RDD. Here you can see the result. Now first I'm going to apply sortBykey to this RDD. So the parameters of sortBykey are order in boolean, number of partitions and function definition. And if you give no arguments to sortBykey, it will just by default sort the data in ascending order. So as you can see in the below command, I've given no arguments in sortBykey and it sorted the data based on the key in ascending order. Now in the next command, I've given some arguments. The first argument was order, so I've given here true. The next was number of partitions, so I've given 3. And the third one is function definition. What I'm doing here is I'm converting the key to lowercase and then I'm sorting the data. So as you can see, here is the result. So I hope you understand sortBykey. Let's take a look what happens when we apply sortBy to the same RDD. Now I'm going to apply sortBy to the previous RDD. But first let's check out the parameters. The first parameter is key function, which is nothing but the function definition. Second is order, which is in boolean. The third one is number of partitions. Key function is a required argument and without it you will get an error. So you can refer this command to get an idea what will happen. So as you can see, I have not given the key function argument here and this is the error I got. SortBy missing one required positional argument, which is key function. Now in the below command I have given that argument rdd.sortBy lambda x colon x1. Basically I'm telling sortBy to sort the data based on this particular key. So I'm asking sortBy to consider the second value as the key. Basically 1, 2, 3, 4 and 5 and sort the data based on these elements. In the below command you can see I'm telling sort by that the first element should be the key, basically these elements. Now based on this, the data is sorted. So I hope you got the idea and the main difference between sort by and sort by key. That's it for this video. Thanks for watching till the end, and if you found it useful then please like the video and share with your friends. You can always refer the playlist to watch my other videos on Pyspark Interview Questions. And finally, don't forget to subscribe, and I'll see you next time.